Good evening, folks. I think we're going to get started. Thank you for your patience. A couple of minutes after 6 this evening. And I want to thank you all for giving up possibly the nicest evening of the year so far and coming inside to talk about sea level rise. My name is Carol Ridley, coordinator for the Pleasant Bay Alliance. And we are here to speak about a new report. We're very happy to release and present to you this evening on sea level rise and its potential impacts to the Nauset Barrier Beach and Inlet System and also the inner shoreline of Pleasant Bay. I thought what I would do first is take a couple of minutes to introduce the Pleasant Bay Alliance. I know many of you are friends and know much about us, but just take a minute to talk about the Alliance and how we came to develop this report and why we came to develop this report. So first, the big view, and hopefully maybe the lights could dim for just a minute. Thank you very much. So Pleasant Bay is a 9,000-acre estuarine system, and the figure on the left shows the outline of what's called the Area of Critical Environmental Concern, or ACEC. That's a state designation that was granted to Pleasant Bay about 30 years ago. Under the auspices of the 4 towns that share the system, Brewster, Chatham, Harwich, and Orleans. And the reason being is that it's such a unique and beautiful and special place in many, many ways. The state program sets forth a series of criteria that need to be met in terms of the extent and quality and diversity of habitat and natural resources that make up an area of critical environmental concern. And this particular area met them all by far. It's an incredible resource area. And the 4 towns, to their credit, 30 years ago, recognized that and recognized how special it was and how important it was for us to work as a region to protect it. What we also recognized is that it's not just the 9,000-acre estuary we need to be concerned about. It's the entire watershed that contributes to that estuarine system. So on the right, you see in sort of a goldy or yellow color the outlines of the entire watershed of Pleasant Bay. And within that greater watershed, there are several sub-watersheds that drain into different parts of the estuarine system that reaches from Meeting House Pond, essentially, up in Orleans, and for our purposes, study purposes, down to the Chatham Light, although that encompasses Chatham Harbor as well. Now, as I mentioned, the 4 towns that share that resource area got together, fostered this ACEC designation process, Area of Critical Environmental Concern. I don't want to use too many acronyms tonight. And worked together over a period of years collaboratively to develop a resource management program that was the town's commitment to each other and to the citizens of their towns to preserve Pleasant Bay for future generations. And out of that effort came the Alliance. We became the group. So we're basically a group that's made up by the 4 towns. Our steering committee, our committees are appointed by selectmen in each of the 4 towns. And on about a 5-year basis, we develop and update a management plan to coordinate the town actions to address issues in Pleasant Bay. We also work very closely with the Cape Cod Commission, with state environmental agencies, with the Cape Cod National Seashore, which has jurisdiction over that part of North Beach, Nauset Beach. And there is an intermunicipal agreement among those 4 towns. So it's really, you know, we hear a lot about regional coordination, regional collaboration these days. This is something that the 4 towns that share Pleasant Bay have been doing for 30 years now. So it's a pretty impressive commitment. And we're guided by a mission that is really focused on preserving the resource, not as a sanctuary, but as, you know, an ongoing, functioning, sustainable estuarine ecosystem. And so wherever we can, we want to regenerate and protect the health of our coastal systems, water quality, and we want to do that in a way that allows us still to enjoy Pleasant Bay. We don't want it to be off limits. It's a tremendous area for boating, for sailing, for fishing, shellfishing. Folks live and work around the bay. That's a vital part of the heritage. It's why it's so special. And, but we want those activities to be conducted in a way that's very compatible with resource sustainability. And so our management program is fairly broad-ranging. We look at biodiversity issues, protecting our coastal resources and wetlands, watershed planning, so we do a lot of work on the nitrogen management issues that you hear about in terms of sewering and aquaculture for nitrogen uptake and that sort of thing, navigation safety, fisheries management, and public access. And tonight we're really going to be focusing on some of the work of our coastal processes work group. So we have a couple of key committees that are appointed by selectmen in each of the 4 towns, and then those 2 committees form a number of work groups that focus on specific topics and issues and projects in each of these areas. And the 2 reports that we're going to talk about this evening, the sea level rise report and the erosion management guidelines, were developed under the auspices of our coastal work group. And I just want to take a moment to identify some of the members of that work group, because these folks they meet monthly for several hours and really go through the detail on all of these issues and really devote a tremendous amount of time and expertise. And so Greg Berman, who is with the Woods Hole Sea Grant Program and the Barnstable County Extension Service, is part of our work group. Judith Bruce, who's our steering committee member from Orleans. George Cooper, a citizen of Chatham. Jane Harris, steering committee member for Chatham. Ted Keon, Coastal Resources Director here in Chatham. Fran McLennan, a steering committee member from Orleans. Steve McKenna, who is with the Office of Coastal Zone Management in Massachusetts. Chris Miller, a Natural Resources Director for the town of Brewster. Amy Usowski, who's the conservation agent for the town of Harwich. And Nicole Smith, who is the Assistant Conservation Administrator for the town of Harwich. And these folks put a lot of time in. We also work closely with Mark's group at Center for Coastal Studies. Graham Geis is a great contributor of our group as well, and many others. So we're very fortunate to have very dedicated citizens, very knowledgeable local personnel and resource management, and many, many organizations that we can draw resources and technical expertise from. So I just want to give a nod to those folks. And of course, Alan Thompson, chair of our steering committee, sitting right here, who's been with us from the beginning of the Alliance. So thank you, Alan. So getting back to our focus this evening is really about the work of our coastal work group and the important role that coastal processes play in a vital, healthy estuary. So we know Pleasant Bay is important as a nursery area, as a breeding grounds, as a foraging area. You know, it's really sort of the ground zero for the aquatic food chain. And that's because we have marshes, we have dunes, we have beaches, we have a variety of intertidal habitats. And those are all created and sustained because we have very healthy functioning coastal systems, coastal landforms, movement of sediment, feeding of marshes, and that means some erosion as well. But that is really what makes the whole system work. So part of our focus is on how do we ensure that those coastal processes can continue while also respecting the fact that, you know, erosion is an issue that needs to be managed, both on public and private property. So we work very hard to understand the problem. We are very science-based in terms of first quantifying, understanding, getting data to help us understand what the scope of the problem is and where we think things might be going into the future as best we can predict using best available science and models. And when I say we, it's the expanded we. Folks like Mark and his group and others, many, many talented firms that we've worked with over the years. So we do, on an ongoing basis, consult with the Center for Coastal Studies, Graham Geis. We helped to sponsor 2 tide gauges, one that's located at the Fish Pier in Chatham and one that's located in Meeting House Pond. And by reading on a pretty constant basis tide levels at those 2 gauges, and with the expertise Graham brings to the process, we're able to understand what's happening with coastal dynamics, what's happening to the inlet and barrier beach configuration, and where that is in the cycle. And Mark's going to get to that in some of his presentation in a little bit. But that helps us understand where we are in terms of system dynamics and where things may be heading that can affect Pleasant Bay resources. And so that brings us to our study this evening because sea level rise is something that we're all aware of to one degree or another. And it's one of those terms that's a little bit, of concern because we don't necessarily really understand it. What does it mean? Where does it come from? How quickly is this going to happen? And am I going to be able to notice it? Is it going to affect my property or where I like to go to the beach? So we felt it was really important for this topic, among others, to get to the bottom of it in terms of the best available science. And so we put out an RFP, and we're very impressed with the proposal that Mark and his team put together to really help us understand what is the likely range of sea level rise in the next century. What would the impact of that be on the barrier beach and inlet system? And what would the impact of that likely be on the inner shoreline and our intertidal resources of Pleasant Bay? And with that information, we think that's a tremendous resource for our towns to have available as they need to make decisions about public infrastructure, our town landings and public access ways, looking for ways to allow those vital salt marshes to migrate landward. Lots of decisions that take a lot of time to figure out. So the more information we have, the sooner we have it, the better. But we also understood that we need to be mindful as we make these management choices that we always have in mind how important it is for those coastal processes to be allowed to continue. And so sort of as a tandem document we've developed to the report that Mark's developed, the Alliance has developed draft guidelines for managing erosion that we have relied on a lot of existing resources and regulations and best practices out there. We view these as a tool for folks who live on the coast, who live on the shoreline, for conservation agents and conservation commission members, and anyone who's interested. Practitioners who maybe are helping folks who are looking for ways to deal with erosion. So we put these erosion management guidelines out for public comment. We are inviting public comment through June 30th. And you can email comments to me. You can mail them to the Alliance. We do the only requirement is they be in writing. They don't have to be in any particular format, but just so that we have them, we can distribute them and really analyze and discuss the comments we receive. And we will be circulating this document to the conservation commissions and some practitioners in the area to get some critical feedback. So that's our objective. And so with that set up, I guess, now for the fun part. And I just want to welcome Mark Borelli. We've been working with Mark for a long time now, over the years. And it's a pleasure. He's a brilliant guy, and he's really, I think, not only helped the Alliance, but other communities on the Cape really understand our coastal geology. So Mark is a PhD. He's a coastal geologist with the Center for Coastal Studies in Provincetown, and we're delighted to have you here this evening.
Thank you. Thanks very much. You should probably wait for the applause, see if it's any good, then you can applaud later. All right. Okay, so let's just jump right in. Thanks for having me. This is it's always a pleasure to work with Pleasant Bay Alliance. So I don't know if should we darken it a little more? Can everybody see okay? We're good? All right. So this is the outline of the talk. Basically, the Alliance asked us to do three things. We wanted to look at sea level rise as it relates to Nauset Barrier Beach and Pleasant Bay. We wanted to look at geomorphological changes of the barrier beach and the inlet systems as it relates to that sea level rise, and then look at the inner shoreline and look at how that's going to change over time. So we're going to walk through each one. What I'll do is I'll put wherever we are at the bottom of the slide so we all know where we are, right? Okay, so this is sea level from the Boston tide gauge from 1920 to the present day. But what is sea level, right? When we talk about sea level, what do we mean? So when we look at the Boston sea level tide gauge, this is what we have for a rate of sea level rise. And we can just think about this as 3 millimeters per year. It's about a foot a century. So for the last century, it's been about a foot, right? Sea level has come up a foot. But like I said, when we talk about sea level rise, what exactly do we mean? It's a little quiz here. All right, when we talk about sea level rise, we're talking about tides, storm surge, wave setup. This is when the wind blows in the water and the water gets higher, or set down. The opposite happens. And seasonal variations, all the above, none of the above, none. Right? When we talk about sea level, we talk about none of those things. So when we see that tide, the tide level, all those things are factored out. This is the natural variability that we have in sea level through time. where we take all the other stuff out. So when we talk about sea level rise, this is what we're talking about. And this is what we've measured from 1920 to the present day in Boston, right? So the other thing we're going to talk about is eustatic or global sea level rise and versus relative or regional sea level rise. Global sea level rise is just that. It's what's going on throughout the globe, right? It's relatively consistent throughout the globe. But then you have regional sea level rise, and that changes everywhere, right? So we'll talk about those two. They're not interchangeable. They're totally different. So we have to be careful. In the report, we're very careful about which one we're talking about. And tonight, I'm going to try and be careful when I talk about sea level rise, what we're talking about. Okay. So a couple more things just to get started. This slide is from the Intergovernmental Panel on Climate Change, the IPCC. This is literally hundreds of world-class scientists that get together and put out a report every 4 or 5 years. And these are the data that we're going to use when we talk about global sea level rise. And I can tell you, if you get this many scientists in a room writing a report and they actually agree on things, that in and of itself is an accomplishment. So these guys, they do a lot of work, and it's very well respected. So when we talk about sea level rise, the big things that we're talking about, groundwater, discharge, addition, subsidence, uplift, ocean currents, temperatures, melting ice. But again, there's a difference between global and relative. The R's are what affects relative sea level rise, and the G's are what affects global sea level rise. When we have ice sheet melting, that's going to affect global sea level rise, right? Eventually, that's going to affect global sea level rise. When we have things like groundwater and subsidence, what's going on in Louisiana, where they have very, very high rates of relative sea level rise, that's part of the reason. Ocean currents can actually change relative or regional sea level rise. So again, just keep that in the back of your mind as we go forward. Okay, all models are not created equal. I want to talk a little bit about modeling because we had to use some modeling. The guys, John Ramsey and Sean Kelly from Applied Coastal, did some modeling for us for specifically Pleasant Bay. But we're going to talk about climate models and sea level rise models really quickly because we're using them in here and we want to talk about it. So the first IPCC report was done in 1991, right? This is what they've measured with tide gauge from 1970, and then they projected out into the future. Now this is 1991. Imagine the power of the computers in 1991 to do this modeling, right? You have more powerful computers in your pocket than they had back then. So what do? They made a prediction, and the gray is where their prediction was, a high or a low, and the blue and the red is what they measured when they did a report years later, right? When they put out a report in 2013, they looked back and see how good their projection was. Well, the reality was it was right at the top of their projected numbers, okay? So they did a model. The gray is the range that model said, well, could be anywhere in here, is what they thought. And where it was right at the top of it, okay? They did the same thing. In 2001, they made a projection. And once again, the dotted black line is where the actual data happened. So the pink is their range of where sea level rise could be, and this is global sea level rise, based on what we did, based on how much CO2 we put in the atmosphere and methane and other greenhouse gases. And this is their projection, and the black dotted lines is where we actually came out. So we're pretty good at modeling this stuff. We're getting better and better at modeling this stuff. So when we talk about the sea level rise models that we used here, there's a reason why we use these. Okay, so this is the latest one. This is from 2014, and this is what they think globally is going to happen given different scenarios. So these are the numbers we're going to look at, and these are the numbers we want to talk about. And it's about a foot to 3 feet by 2100, right? Because the current rate is about a foot per century. So they're going to stick with that as the low end, and it's up to 3 feet. And again, this is now thinking 3 years back, 4 years back. A lot of people think it's conservative, right? They think it's going to be more than this. You hear stories about 5, or reports rather about 5, 6. Some people say 8 feet of sea level rise, worst case scenario. But this is the model they used. These guys are the best, and this is what we're going to use, right? We want to start with the best we can get. So we look at the longest tide record in the Northeast. It's in New York. There's a little blip, but from the 1860s, 1855, 1860, they have a considerable record of tide heights or sea level. So what they did in the IPCC is they started doing regional sea level rise models. So they did one for New York, right? So now they have a regional. It's not only global, but it's actually regional, and it's about 1 foot to 2 feet to 3 feet in 100 years. So it's similar to the global one, but it was tied into the regional one using that data. So what we did, Graham actually, looked at the trends in Boston and looked at the trends in New York, and they're very similar. So we're going to use, the reason why we chose the sea level rise models that we did is because they're similar to New York, and the IPCC did a regional model for New York, so we're using that one because it's very similar. So this is the figure that comes from the report, and you can easily call it 21st century Pleasant Bay sea level, right? Now, there's other things that are going to affect, obviously, the water level in Pleasant Bay, but as far as sea level goes, regional sea level, these are the numbers we're using in the report. It's basically 1 foot, 2 foot, or 3 feet of sea level rise by 2100. So that's our range, right? And these are the actual numbers, but just again, for clarity's sake, we're just going to say 1, 2, and 3 feet, right? And if there's any questions, you might as well stop me in the middle, right? Don't just raise your hand or call my name or say something, because if we get to the end, then we'll miss stuff. So feel free to stop me anytime. Okay, so that's the basis of how we chose the sea level models that we did. Now we're going to talk about the geomorphical changes in the barrier beach system and the inlet system, right? So basically, we're going to have phase 2 and phase 3. Phase 2 is only going to be about the barrier system. And phase 3 is going to deal with the inland shoreline. Now, this is a great report. We did a lot of work, but there's only so much you can do, right? We can't do everything. And what the Alliance, the way they steered us was in this direction, because we just don't have so much time, so much funding. So we decided to go in this route. So the next phase we're going to talk about is how we think the barrier beach is going to change with sea level rise through 2100, right? This figure is so comforting to me. I know I'm home when I see this figure. This is Graham's figure from the 1980s, late 1980s, before the inlet was formed, predicting where the inlet was going to form, and he came really close, right? So we have a really, really good history from the 1770s all the way through to the present day. A lot of maps, a lot of charts, and we looked at this 140, 150-year cycle of inlet formation, spit accretion, or elongation, and then another inlet forms, right? And there's that cycle. They did a report. This is really cool. I'm going to step aside here just to stop for a second. This is a report that we did, or Graham and Steve did. I was a little part of this for the Pleasant Bay Alliance a little while back, looking at changes through time, 1860s, 1870s, how this forms. And it's because we have this study that was also funded by the Pleasant Bay Alliance that we can build on these studies. This work's already done. We don't have to go do it again, and this is a considerable amount of work. But using these data, this is 2009 when the study was formed, 2017, 2027, and 10 years into the future. Graham is fearless when it comes to predicting things. Most scientists won't do this. All right, so we can build on this. We can use this. We did a little bit of work for this particular question. That was sort of two-dimensional, like everything's three-dimensional, right? All these things have processes, and you have to understand tides and currents and sea level rise and things like that. But we wanted to look at it in a different way. We wanted to look at the cross-sectional area of these barriers, right? How persistent is the volume of this barrier? When I mean volume, I mean if you look at the area under this particular curve, right? We want to look at it through time. So we got 3 data sets. We got one from the 1880s, one from the 1950s, and the most current one was from 2010. And we just drew these transects all along the barrier. We got 10 lines, and we looked at the change over time. And what's happening is, we'll just look at one area in particular, it's doing a pretty good job of what we call barrier rollover. It just migrates landward. This is what you want a barrier to do, right? You want a barrier to wash over, so when there's storms, sand washes over the low areas, and then it builds up in elevation, and it slowly moves landward. This is a healthy barrier. This is a natural barrier. This is what barriers want to do. This is what they need to do to keep pace with sea level rise. If they can drown in place. There's a lot of instances, I keep mentioning Louisiana, where the barrier islands are just going away. There's not enough sand to keep pace. They're not wide enough, they're not high enough, and they can't roll over because there's just not enough sand to keep them going, and they can't keep pace with sea level rise, so they get thinner and thinner and thinner, and they disappear. And that's been really well documented in Louisiana, in the Gulf of Mexico. So that's what we don't want to have happen. Yeah?
If the inland is walled, so it can't move to fit when the area moves, does that make a difference?
Yes, that's the mainland. So that's on the mainland. We're going to talk about that at the end. You're skipping ahead to the good parts, but that's okay. It's a great question because they do put revetments and seawalls and structures on barrier islands too, all over the place, all throughout America, all throughout the world. They do that, and you know the wisdom of putting a permanent structure on a moving landform we can talk about all night. But it's done, and it's done a lot. You know, you think about North Carolina and Florida and all kinds of places up and down the East Coast, Gulf of Mexico, happens all the time. Somebody says situate, yeah. So you can look a lot closer to home. So that's a concern, especially on a barrier island. It's really, really difficult to do in Massachusetts, especially a new structure, because we kind of learned our lesson. But we're going to get to the mainland too, and that's a great question. But they call this a barrier spit, a barrier island, a barrier beach for a reason, because that's your barrier. It keeps you protected from the open ocean. So this is a good thing. This is literally your first line of defense, right? So this is healthy barrier. It's doing exactly what you want it to do. And that's what we saw when we did this analysis. So that helps us understand what's going to happen into the future and gives us more confidence. There's not a lot of variability here. If you try and predict what's going to happen with the inlets, there's a lot of variability there, right? Nobody knows what's going to happen with the inlets. But these are really doing well. They're keeping pace with sea level rise. They got a good height to them. They got a good width to them, and they're just sort of moving landward. This is a classic. You couldn't draw a better picture for a barrier that's moving landward, right? So boom, boom, boom. This is good. So you guys are in pretty good shape as far as that goes. All right. So what we do now is we take 2016, which is when we started this, and then we look into the future. And we're using expert opinion, we're using our best judgment, we're using the data that we have from those profiles, and we're looking at how this is going to change through time. And this is the low sea level rise scenario. So the low is 1 foot, the medium is 2 foot per century, and the high is 3 foot per century. I mean, that slide we show. So there's low, medium, and high. So for the low, this is what we see. It's sort of business as usual. That 150-year cycle continues of inlet formation, spit elongation, and then another formation. When you go to the mid one, it starts to change. So let's look at, say, 2040, the one over here. And you look at as it goes from low to medium to high. And what's going to happen is, so that's low, medium, high. The spits get longer, right? This cycle is because of sea level rise. What we're saying is because of sea level rise, this cycle is going to get faster, right? There's going to be more action, more sand transport.
If you want to move, you should use this.
Oh, okay.
Or stick to the mic.
Because we're recording.
Yes.
Okay. All right. Thank you. So you can hear me? It's good? All right. Well, I know you guys can hear me, but you can hear me at home. So, okay. So does that make sense? So because the sea level rise, we think, we're pretty confident that this cycle is going to get faster. So in other words, it's going to increase the variability more, which Ted Keon is really happy to hear, right? It's going to get more complicated. It's going to get trickier. So this is what we're seeing. This is what we saw from the medium, and you can read this in the report: low, medium, and high. So that's what we think is going to happen. The report details why, but again, part of it is because higher sea level, waves are getting closer. You're going to have more erosion. You're going to have more sand moving. It's going to reach further in than it normally would have. So we think more sand is going to be more active, and the storms are higher, and that's where you get your inlets forming during storms. So we think it's going to just accelerate that cycle. All right. I had to throw this in here. This comes up every once in a while. I hear this question a lot. Could there ever be an inlet formed up at Poche? Right? This is a question we get a lot. So I just got a couple images in here. 2004, 2005. That little washover fan right up there. I'll show you again. 2004, 2005. That's what you want. That's a washover fan. That's a barrier keeping pace with sea level rise. It's a low area. There's a storm. Where does water go? It goes in the lowest spot. I can tell you where the lowest spot was before that storm because that's where the sand went. Boom. There's a big one, right? Same place, much bigger. Starts to go away, 2012, bang, all over, right? So all over, this barrier just got about that much higher. Now, how much sea level rise is that? If that's like 6 inches, you can go out there and dig it up. If that's 6 inches, you just bought 50 years of sea level rise in one storm. One good storm, you can get 5, 6 inches, you can even get more. And that's how barriers keep pace with sea level rise. That's why it's important not to mess around with them, because this has to happen. Overwash has to happen. If it doesn't, the barrier goes away. If it does, usually means you're in good shape. Because, like I said, your barrier just got taller in one shot, just got higher in elevation. And you created all this habitat, too. Plovers are dancing around. They're all excited. So we keep going, 2015, a little more, right? That's a new one, especially down on the bottom. So just from 2004, let's go back and forth. Over the 10, 11 years, it's a lot of sand. If you guys were going to pay for that sand to get put on that island, forget it, right? It would probably be tens of millions of dollars easy. Not that you get permits to do it anyway, but Nature's doing for you free if you just let it do its thing. So this is what we're going to talk about as we go through this, is that this is a natural process, and it's working great because we're not involved, which is usually the case, right? All right. So last thing we'll talk about is the inner shoreline. What's going to happen on the inner shoreline given all the changes that we're seeing with sea level rise, or that we think are going to happen with sea level rise? Okay, so very generally, this is just sort of a sketch, little thought experiment here. You have an intertidal area, right? You have mean low water, mean high water, open ocean beach, very narrow, so you have a very small intertidal area, right? Sea level rises, you still have a very small intertidal area. It just kind of marches up the profile, right? That's okay. Now, think Brewster Flats. You got a quarter of a mile, you got a half a mile. Now if sea level rises and it can't do anything else, you go from this to that. It's got nowhere else to go, right? The intertidal just can't move landward unless the beach and the area behind that intertidal keeps eroding, right? We can do it on the beach, on the ocean side, because the seashore is just going to let it erode. It's much harder to do on the mainland shoreline because, people are there. So that's something to keep in mind. This is what could happen to intertidal areas, and there's no scale here because it's just an idea to keep in mind as we go forward. So we go from time 1, where you had a big intertidal, to time 2, because it's not allowed to erode in this area. All right, so now we'll talk about Pleasant Bay. So here we are north of Big Bay. These are all structures here. The blue line is structures. This is the low, medium, and high scenario, and this is our intertidal. So green is all intertidal right now. Yellow is where we're going to get intertidal 2040, orange is 2070, and red is 2100. So in 2100, if we don't do anything, right? If we don't do anything, all this is going to be intertidal because it's going to finally get up high enough to flood that area. That's the only way you can kind of do these things. You can't imagine what someone's going to do in the future in terms of what you're going to do to prevent or allow inundation to happen. So we just did sort of a thought experiment of what would happen if everything stayed as it was. All right? So that's the medium and the high. So now if you notice, high here, there's actually, in 2070, this all gets flooded, not in 2100. So the high, that's going to get flooded earlier. So if we look at a chart of you got about 400 acres of intertidal area on the mainland. We didn't do the barrier. Now remember, this last part is just the inner shoreline. We didn't look at the barrier. So we just want to look at the inner shoreline. So this is where your starting point is. You got 3 different scenarios. You're losing intertidal, right, no matter what the scenario is, until 2040. And then in 2070, you're losing here, but you're gaining a little here because more areas are getting flooded, right? More areas are getting flooded. But overall, these 2 areas, you're losing intertidal. But if it really goes fast, if you get a lot of sea level rise, you're going to gain intertidal. But the question is, will you allow that to flood? Right? Are we going to allow all that area to flood? We might. You might not. So you got to take these numbers, not with a grain of salt, but you got to take them in the right context. Right? If you're a proponent of intertidal area and you think, ooh, we're going to get a lot of intertidal area, if it really starts to elevate with sea level rise, well, that might not happen because we might not let it happen. So it's something to keep in mind when we talk about future scenarios for intertidal areas. Does that make sense? All right. Sometimes I say things that don't make sense, so you can just stop me. All right, so the last thing we talked about in the report is coastal engineering structures. So John Ramsey, again, and Sean Kelly from Applied Coastal did some modeling of the inlets, and I should have mentioned that earlier because that helped us understand how the inlets were going to form for that step 2 for phase 2. And I should have mentioned that, but I'm not a modeler, so I don't want to get too deep into it. The report talks about it. But so not only did they do this, but John wrote up some of the coastal engineering stuff for the structures. And this is out in Pleasant Bay, obviously. And the thing to remember about structures is that on a natural beach, right, you have sea level rise. You get your beach width here, your intertidal area, if you will. And then you have the sea level rise, and it just moves up, right? We just take that intertidal area, and it just moves up with sea level rise, like we talked about before. Now we put a structure there. You put a seawall, and you have that same amount of sea level rise. It's got nowhere to go. And this is what we're talking about. It's got nowhere to go because the wall's there. And the wall's doing a job. The wall's protecting what's behind it. But we've got to be clear when we're talking about these structures of what they're doing and what they're not doing. The structures are protecting what's behind it. But in a lot of cases, you're going to lose what's in front of it. Right? So that's the challenge here. In a perfect world, we could do both. We could protect everything and we could not lose any of the resource. And then what we call ecosystem services. Because the intertidal area is fantastic for ecosystem services. It's habitat, it's nursery, everything likes to live there. You got birds, shellfish, all kinds of stuff. So we talk about coastal engineering structures, and we're going to look at this. So now in this figure, the black are the engineering structures, right? Notice what's happening here. This is not magic. These two are related. There's no intertidal here, right? So the colors, the green is the intertidal area in 2016. There is no intertidal area in this area in Pleasant Bay, and it's largely because of that structure. What I just showed in that last figure has happened here. It's already happened. This is, again, we're north of Big Bay. This is 28 right here, northern part of Big Bay. I don't know, what would we call this area? Oh, okay, yeah, Wauquasit, yeah. Yeah, Wauquasit's just down here, right? It's right here. Where's Jackknife Cove? It's south. It's south off this figure. Yeah, so this is the figure. This red box signifies where we are in Pleasant Bay. Sorry, should have made that more clear. See, I'm not messing up a local name. That's not going to happen. I'd rather play ignorant. All right. Okay, so this is the low scenario. So now you got to watch what happens as we go. This is what we have in 2016, and this is where the intertidal line is going to be under the low scenario. And this is what we have it in the mid scenario and in the high. So you see what happens. I'm just going to cycle through these. So it just keeps it migrates. If you look at the thickness here, it very nicely sort of migrates landward because there's no structures there. If we were to allow it to do that, it's just going to migrate landward. You're not losing much intertidal here. But if you look it down by the structure here, it just gets thinner and thinner and thinner because the structure's there. Again, it's got no place to go. Right? That's where it starts. That's where it ends.
Does that push the groundwater higher?
Does it push the groundwater higher? It can. Over time, it could be a problem. It can change it, but that's sort of a really long-term problem. Yeah, you'll get saltwater intrusion, but that's not eventually.
Right now, it's underlying that.
Yeah, I mean, freshwater's thinner. I mean, freshwater's always going to rest on top of the saltwater. It's less dense, so it can do that, yes. Not necessarily. It's not linear like that. And I'm not a hydrologist, and I don't want to get myself into trouble. But it's not that linear. And there is some lag time in between, and so I don't know the answer to that question. If anybody does feel comfortable talking about it, no. Okay. All right, we're all in agreement then. Okay. So same kind of thing here. Just want to show, this is the figure that we showed earlier. But again, look at the intertidal area, all the green, and then the blue are structures. The thinnest area, or the areas where there's no intertidal, is right where the structures are. So you're getting all this intertidal benefit right now, except in the areas where you have the structures. So the structures it's already happening, right? You're already losing intertidal area because of the structures. And you can imagine what would happen if structures were built here. And this is not this is not a good or bad. This is just what will likely happen if structures were put there. You're going to lose the intertidal because there's no place for it to go. All right. This is one of the figures again from Pleasant Bay, and you can see it here. You got your structure, you got your erosion in between the structure. The shoreline's like this, and then it goes like this. Same thing here, all structure, and then boom. It's called end effects. So the structure does its job, but when there's no structure there, it's going to erode. And it's going to erode preferentially a little faster at the end of a structure because all the energy that's going to hit this area is going to accelerate. I mean, this was, in the not too distant past, relatively straight shoreline, I'm sure, right? You put that structure there, you're going to protect what's here, but you're going to accelerate erosion in the ends. You're going to accelerate erosion where the structure doesn't exist. And this is not new, right? This is really well understood and established in settled science. That's all I really have. I'm not a big finish, but this, I saved that. This is Jackknife Cove right here.
Thank you so much. And so we do have time for some questions.
Yeah,
and I'm just going to walk around with the mic because we are recording this meeting, and it's just helpful to hear your voices. So I'll walk around if anyone has a question. And before I do that, I just want to mention, because we did have copies of both the sea level rise report and the draft guidelines. If you did not get a copy, they are both on our website. www.pleasantbay.org. So Pleasant Bay, all one word, .org. They're on the home page. You just scroll down and you can get them online. So, question? Yes.
Jim Mackey, South Orleans. I've only been here for 12 years, so I'm a wash ashore. But on the other hand, I have a home that overlooks the Cape Cod National Seashore. And I know you're very good at what you do, obviously, and Carol is doing an outstanding job.
Mm-hmm.
But I can tell you, as a person that's been here for 12 years, the sand dune is getting lower and lower and lower.
Right.
So in other words, you seem to be focused not on the height of the Cape Cod National Seashore is getting lower, so I can see more of the ocean. In your analyses, do you account for that blowover of the sand into Pleasant Bay and recognize that the shoreline is getting lower?
Right. We didn't address that precisely because, again, we were limited by the scope and the time. But that is an issue. And looking at those profiles of those 10 areas, there were places that are lower in elevation. Yeah. So that's one thing. Elevation is definitely critical. Barrier width and height in general is also important too. So that one frontal dune can get lower and it can be a problem. There's no doubt about it. But overall, if the island is higher, if you don't have that one big frontal dune, but you have a wider, flatter dune as it starts to migrate landward, so that can be a problem, what you're describing, but it might not be. It depends. It depends on exactly what's going on there, but that's interesting to hear. Thank you.
Next question. Mark, this is Kevin from East Orleans, and kind of a two-part question, and it relates to storm activity.
Mm-hmm.
Did your forecast look back at the severity of storms, and can you confirm what we all have been told, and I think we believe it after seeing it for enough years, that the severity of storms is much more intense? So given that intensity, have you used that storm intensity in the forecast and models?
No. No, we didn't. No, it's clear that it looks convincing that storms, while they may not be increasing in frequency necessarily, the severity of the storms and the intensity of storms is increasing, especially for hurricanes, right? We've seen that. There may be less hurricanes or fewer hurricanes, but it seems like they're getting more and more intense. So we didn't factor that in because, storm variability is a study unto itself, right? So over the long haul, over 100 years, you assume a certain amount of storm activity, but we didn't really factor it into, because that would have been, again, that's a whole study unto itself. But great question, yeah. I mean, a lot of this is driven by storms, quite frankly. Sea level rise, we can measure, we can watch. If you were to have an extremely quiet 50 years or an extremely noisy 50 years, it's going to change everything. I'm a storm guy. Yeah?
Other questions? Oh,
Anyone want to?
I've done it before.
Okay.
Barbara Waters in Chatham, 45 years. And I was fortunate to come to see all these changes because I'm a science teacher and very interested in earth science. And one thing I've noticed is I'm wondering in the throat, we call Aunt Lydia's Cove by the fish pier, the throat of the bay.
Okay.
You have a landform you're saying is going to run back down again like it has in the past, but it's all walling off there. It's getting walled off. So the inland isn't going to move, so it's going to get narrow and narrow. How close can the beach come before it starts forming?
That's an excellent, excellent question. I am personally, it would make sense to me as a scientist that the structures that have been put in place are going to alter the way Chatham Harbor evolves through time. That just makes sense to me because the shoreline can no longer migrate, right? It can't move landward anymore. So when we talked about those areas going away, and I think you can partly see that at the hallway revetment, right? It's really, really deep. It's deeper than it's ever been in the past. And part of that,
70 feet?
it has been up to 70 feet in the past. Yeah, I think it might be a little shallower now, but that's unnaturally deep.
Yes, I know.
I mean, it's never been, you can look at the historic charts. We have charts going back to the 1800s and even earlier. It's never been that deep before. And it's in part because a lot of forces are acting against it, wherein it's sort of pushing against that revetment. And you have to have so much water going through there twice a day. So if it can't get wider, it's got to get deeper. And that's what's happening. So there's no doubt in my mind that the structures that are already here are going to change the way this area evolves into the future. How? I know I keep saying this, is a whole nother study. I'm not really fishing for work, but it really is. It's incredibly complex, and how that's going to affect it. It already, like you said, you're seeing it. It already has. Yeah.
Bob Perry. I'm on Little Pleasant Bay of Salt Marsh. I've been down here 48 years, and when I first came down here, we had a tidal range of maybe 18 to 20 inches.
Mm-hmm.
Now we're up to like 3.5 feet.
Yeah.
Now it appears that this year, talking to the fishermen, oyster beds out there,
Yeah.
that they're saying that the tide's not going out all the way right now.
Yeah.
And that where they had flats, now they got a foot of water at low tide. What kind of a cycle can we expect into the future?
So that's the study that Graham Gleiss has been working on for the Pleasant Bay Alliance, and thankfully Graham has this knack of putting things in place just at the right time. He put a tide gauge in Meeting House Pond just before 2007 Inlet opened. He put a tide gauge in Outermost Harbor about 2-3 weeks before the April Fool's Inlet opened. So because those tide gauges are there, he has seen this. There's a report out, and we reference it in the study that talks about that. And what he thinks he's seeing, because he has the tide gauge in Meeting House and tide gauge in Analytia's, he thinks he's seeing the south inlet, the 87 inlet, and I always call them by the years or else you guys go crazy. The 87 inlet, we're getting recorded, might be starting to close, might be starting to become less of the primary one, and the 07 inlet might start, capture more of that tidal prison and open up. So that's what he's seeing in the data. The fact that you're telling me that the fishermen are seeing it makes me very happy, because they typically know what's going on before we do, right? So that's.
I talked to David
Yeah.
down there.
I like that. That's good, because I like it when science gets corroborated by real world stuff. Not that we're not real world. We're not making this stuff up, but it's good to yeah. So I think that's what's happening. I think it looks like it's slowing down. The 87 inlet's slowing down. Now, what effect the 2007 inlet to the 2017, the new one, is going to have on the 87 one? Well, that's a study all itself. That's a whole other study.
Hi, I'm Bob Zaremba. I've been here 50 years. This is my 50th year in Chatham, and I've too seen the inlets.
Competition building here.
I've seen the inlets inlets move, and one of the things I want to reemphasize what Barbara Waters had to say about stabilizing the interior of the shoreline. I don't have the number in my head exactly, but in the last inlet cycle, following the inlets in the 1870s, I believe, there was a period of erosion that took out our twin lights, and we moved our twin lights back. I believe there was approximately 300 feet of erosion at Chatham Light. Mm-hmm. And in my mind, that was erosion that compensated for the movement of water out of Pleasant Bay during storm events when there was a big storm surge and it moved out of the bay. Right. And I think that that's going to continue to happen, but with a stabilized shoreline, that water is going to be moving very fast. And I don't personally see, and I've talked to a number of people about this over the years, I don't personally see a way that the inlet, the barrier beach system, as you've shown it, can reform in front of the area from about the fish pier south. It seems to me that will never happen again until you have the concomitant amount of erosion that will accommodate the reformation of the barrier beach. And I think that has huge implications for what the old village is going to be confronting with basically open ocean conditions there during storms. Right. And I think that the story of the sand will be that there'll still be the same amount of sand moving down along the outer shore, but it'll move really fast through that area with 70-foot deep channels, which you've documented, and that there'll be a bigger structure in Monomoy and the areas south of there. But where we've stabilized the shoreline, there's going to be something to pay attention to.
Yeah, and you're seeing that, the last, 5 or 6 years, the currents are so fast off the beach there that they've had to put jet skis and, in case people get in trouble and that kind of thing. So there's been some hairy episodes down there. So yeah, you're right, it's happening.
Hi, Rich Naffler.
Yeah,
Just a question on the maps themselves. Are they something that are they available? The low, medium, and high maps that show the shoreline, are they available for homeowners to use in assessing? Are they accurate enough for that use, or is it more theoretical?
No, well, they weren't designed to do, plot by plot. That's definitely not what they were designed to do, and that's why we didn't zoom in, much more than we did, because that's not what it was for. It's so far into the future, 2040, 2070, 2100, and it's so variable. This is just giving us an idea of what could happen.
Okay.
So yeah, it would be a misuse of the data to do that, to be honest. We'll get you.
Michael Westgate, Chatham, coming here for 77 years.
All right, that's got to be the winner.
Question both for you and for Carol. In the report, it states that Pleasant Bay may lose a quarter to half of its 392 acres.
Mm-hmm.
And a question in terms of marsh migration and public policy, and how do you grapple with that versus individual homeowners, property owners' rights?
Mm-hmm. Yes. It will be grappled with.
Well, it's a very good question, and there isn't a very good answer for it this evening. But I mean, I think the whole purpose of this is to raise those questions. So I think now with this information, towns, land trusts, open space committees, conservation commissions can be aware of the need for that opportunity for marsh migration, and to begin to think about ways to accomplish that, whether it's through acquisitions or undevelopment of certain properties, if that becomes an opportunity at some point in time. I'm sure lots of land specialists have many more ideas than I have, but I think, again, the purpose of this study was to provide a baseline of information for those kinds of conversations to take place.
Back there.
Mark,
Yes.
do you project North Beach reconnecting with Monomoy?
Oh, sure. Eventually, yeah. The question is when, right? Yeah, that's definitely in the cards. It looks like it would be in keeping with the cycle, right? So yeah.
Because it looked like that was the case previously.
Oh, absolutely. Yes, sure. It was very much so, and I think it will happen in the future. Sure. Just a question of when. And we have some cycles there. There's a couple questions in the back too.
Oh, okay, sure. And this side of the room, come on.
Hi, I'm Dave from Orleans. I just had a question. So we're talking about the migration of the inlets, but since I've been alive, I'm one of those horrible people that drives up and down the beach, and we have lost. I mean, like it feels like since I'm 39. I know I'm the youngest, probably Cape Codder here, but I've been on that beach since I was a baby,
Right.
and it seems like we've lost hundreds of yards. So So in your model, you're saying the barrier beach is still going to be there in 2100.
Right.
So my theory is it's going to be oceanfront property if we keep losing it at the rate that we've lost it in my lifetime.
Right. So the question becomes, it's easier to see the loss than it is to notice the gain, because you don't really go that close to the bay shoreline, right? I mean, you're usually not that close.
Well, you used
And
to
even
be
the
allowed to
stuff-
drive on the inside
right,
when I
and
was
now
little.
It's kind of eroded almost back there.
Yeah.
Yeah. So what'll
So
happen
it's
is
thinner all the way through.
Yeah, no, that's a great observation. That helps us better understand what's going on out there, because what I think is happening, because you can look at the models and look at the data all you want, but getting out there, you've been out there more than I have, quite frankly, right? So the idea is, because we're seeing what we're seeing, and I'm hearing what you're saying, there's when this overwash happens, a lot of it will go underwater, right? So a lot of it, when the overwash happens and you see it sort of end by the water's edge, it doesn't really end by the water's edge, it goes down. So you have this situation where the barrier would be like this, and then it's going to start doing this. So the barrier is going to get wider in pulses. So I totally agree that there's been a lot of erosion. And you can see it when I did that 2004 to 2015. You can see it jump landward, right? And you can see, a little that it's getting wider on the bay side too. So the question is, what's that balance? Right now it's keeping pace. Right now it's more or less where it should be, even though you've lost so much there. The volume of sand is the same. The subaerial stuff, the stuff you see at low tide, or high tide rather, is probably getting narrower. But as a geologist, we want to see the whole landform, above and below the water. So what you're seeing is absolutely true, but it doesn't necessarily mean that what we're seeing isn't true either, if you know what I mean. I mean, I totally, yeah, that makes sense. Yep. Yeah.
The follow-up question to that is that if you go back to 50 years,
Mhm.
you may have 500 yards to go to get to the beach at Nauset.
Right.
Now we're talking possibility of losing the parking lot.
Yeah.
So
Oh yeah, no, it's about a couple feet, you know, on average. The rate is like what, 2-3 feet a year.
So,
But that comes in pulses though, right?
But is that going to grow?
Where?
Based on
Whereabouts?
Nauset Beach.
It should, and it has been recently. Like I said, the question is, will it keep up? Will it be able to keep pace with sea level rise? And that depends on the rate of sea level rise. The faster it goes, there isn't a barrier island in the world that wouldn't drown in place given fast enough sea level rise. I mean, if sea level rise goes up fast enough, you're going to lose it. But what we're seeing here with the scenarios that we've shown, it looks like it's going to keep pace with sea level rise because, in large part, the areas to the north are allowed to erode. Because the national seashore allows that area to erode in Orleans and come south, you guys are in much better shape. If this were Plymouth or someplace where they, you know, not to disparage Plymouth, but if there was someplace, if they allowed you to revet that area and not let that bluff erode, you'd be out of luck. Then you'd have major problems. Right now, it looks like you're okay for foreseeable future. But again, like I said, if you get 50 years of bad storms, if you get 5 years of bad storms, it can change fast. But right now, you're looking pretty good. Yeah.
You haven't used Graham's favorite word, relative sea level rise, which includes subsidence, and I'm wondering why you haven't mentioned that.
It's a good question. I don't know. Yeah, I mean, there is a certain amount of subsidence going on here. There's not really subsidence. Well, it's isostatic rebound, and it's started slowing down. And there's also the steric effect where part of the sea level rise is due to warming temperatures. So I didn't want to get too far into the relative. We did talk about a little about relative sea level rise in the beginning, but we didn't get too much into it.
Well, that's all Graham was letting me say.
He's going to be very proud that somebody said that.
Quick question, Sarah
Yeah.
Griscom, Chatham. When you have a foot rise in sea level, you don't lose a foot of land.
No.
Right, so that's something that, you know, you didn't touch upon.
Well, that was when I showed that slide about the intertidal area. We have these big intertidal areas, and they're broad and flat, and the sea level goes up. It goes away fast. You lose a lot of intertidal really, really fast. On the barrier, it's different because the barrier is moving, right? So on the barrier, you're going to have a foot of sea level rise, and the whole barrier just kind of rolls over, and like again, you keep more or less the same volume, but it just moves. So that is a barrier island keeping pace with sea level rise. It's very unlikely that your barrier, Nauset Beach, is going to go away anytime soon. It's very unlikely because it's pretty healthy. I mean, it might not look it, but it's pretty healthy because of a lot of erosion and is low-lying in some areas, things like that. But the mainland is where you're going to have the problem. The mainland is where you're going to have a foot of sea level rise, and it's going to cause major problems, major differences, major changes that you're going to be able to see, in part because you can measure them against something. Right? If you have stairs going somewhere or you have a structure, you can see that year to year. You can say, wow, the high tide's coming up a little higher this year, and I can see it on the wall. You can't do that in the barrier. It's much harder because it's surrounded by water, right? You can do it. It's just trickier. So I think I tried to touch on that. Obviously, I didn't get to it enough. But yeah, on the mainland, a foot of sea level rise could have much more dramatic impacts than a foot of sea level rise on the barrier. I should have said it that way. Thank you.
As the existing marshland gets covered up by sand and drowned and eroded, what's the outlook for the future for the marsh areas?
Right. So
will they be able to regenerate themselves as sea level rises?
Right. I'm a big fan of the National Seashore. They've been doing a lot of work throughout the Cape Cod National Seashore, measuring very, very accurately how the elevation has changes in salt marsh. And some salt marshes in Cape Cod National Seashore are keeping pace with sea level rise. Many are, and some aren't. I think that the ones in Pleasant Bay right now are keeping pace with sea level rise. I think I'm right in saying that. So it's not all bad news when it comes to sea level rise in salt marsh. There are some salt marshes that will actually benefit from a rise in sea level because more sediment will be brought into the system. And that sediment that washes over the salt marsh, or the water that washes over the salt marsh twice a day, if it brings more sediment with it, then it'll keep pace a little bit more. Every high tide, every low tide rather, it'll deposit more sand or more sediment, more fine-grained material on that salt marsh. So it can be good, right? There can be a positive. in that there are some studies. Kerwin at Virginia Institute of Marine Sciences looked at a lot of different studies. He did one of those meta-studies, meta-analyses, and he said there are actually some salt marshes that will benefit from an increase in sea level rise. That doesn't mean all of them will, and that doesn't mean Pleasant Bay will. But right now, I think I'm right in saying that the salt marshes, many of the salt marshes in Pleasant Bay are keeping pace with sea level rise right now.
One more question? Anyone who hasn't had a chance to ask one? Or
Should get another one.
Barbara? Okay.
The coastal banks are also very important as sand source.
Yeah.
And we seem to be covering every coastal bank. I take the first graders down to the Monomoy Wildlife Refuge to show them the contrast between a walled beach, a walled coastal bank, and an open coastal bank.
Sure.
And if somebody wants a good lesson, just walk down those steps, look to your right, no beach. Used to be a beach. You look to your left, and there's a beautiful beach even at the highest tides. And I just want people to realize every time you wall in a coastal bank, that marsh there is going to go under if there's no sand source from the coastal banks to keep it going up higher.
Don't really need to add much to that. You really do pay attention when Graham does these things, don't you?
Well, I want to thank Mark very much for a terrific presentation, a great report. I hope you have a chance to take a look at it. I want to thank you all for coming. And once again, the reports are on our website. If you really want a hard copy and you weren't able to get one, please come and see me after the meeting. And if you are interested in commenting on the draft erosion management guidelines, please either email them or mail them to me, and they will be reviewed by the work group. And once again, thank you very much. Appreciate it. Till June 30th. Thank you.